quick recap of what we kind of introduced at the very end of Wednesday's lecture. Okay, so some of you have seen this before if you use an Arduino. In this class, we're going to make you do it the hard way. I'm not going to go through that whole little soapbox speech again. Again, we talked about motivations both for learning that and practical aspects in terms of it being literally the code being faster and all of that. Okay, so forget that remember from last time. I didn't really get this far last time. If you look at your Arduino, it has this bank of pins labeled digital over on the right. We're not going to worry about what PWM means yet, or the little squiggly signal. And I briefly mentioned last time, these are pins that can be controlled by software and can function either as inputs or outputs. Okay, so if it's an output, it acts like a voltage source. It can provide current, it can set a voltage to something that it's controlling, but it's digital, it can only be high or low. So I haven't actually really used the word analog much, but for pretty much the first half of this course, we were talking about analog circuits where voltage could vary continuously, right? We saw sine waves and derivatives and all sorts of stuff. Right here, it's either high or low, and I'm going to use the words high and low, or true or false, kind of interchange. So for high, we have four things. High, 5 volts, true, or a binary 1, kind of in the 0 and 1 computer sciencey sense. I will use those interchangeably. Same thing for low, 0 volts, off, or 0. Right? All of those just kind of mean the same thing when we're talking about digital. It's either high or low. So if I bounce between those words when giving a lecture, I apologize, but they all mean the same thing. Okay? And I think, okay, I'm not going to stand here and read all of this text. And I will, there aren't really going to be handwritten notes for stuff like this, but I'll post these slides after if you kind of want to read through for the explanation. So you've got a bunch of pins. You can set them as digital outputs where they set a voltage, or as inputs where they read a voltage and they kind of act like a multimeter, right? But they're only going to tell you high or low. They're not going to tell you 2.1 volts or 3.3 volts. It's just going to tell you on or off, okay? General rule going forward, don't use pins 0 and 1. You see the little TX and RX symbols there? Those pins can be used for serial communication, which is a type of digital communication with an external device, but they are also electrically connected to the USB lines that communicate with the computer. So if you have stuff connected to these pins, it can mess up uploading code to your Arduino. So it's fine if you temporarily disconnect something, upload the code, and then plug it back in, but in general, you should have enough other pins that you just don't have to do that. You can literally, if there's nothing else connected to your Arduino, you can hook your oscilloscope up to these pins and you'll see the voltages on those pins fluctuate when you upload a program, because that's how it's sending the data over USB. So just, I don't think it actually matters in Tinkercad, but with your physical Arduino, skip using those going forward unless you've filled up all the other pins and you have to. Okay. I kind of talked about registers last time and we just saw a bunch of 1s and 0s, but now we need to actually explain what they are. Okay. And this is me as a mechanical engineer attempting to explain a very computer sciencey concept, so probably some hand-waviness. There's specific locations in a processor's memory, okay, that contain either 1s or 0s that, for a microcontroller, have special hardware-related functions. And I want to pause to again give a mechanical engineering explanation about the difference between a microcontroller and a processor or a computer. So a microcontroller, think of it as a simpler thing that literally just has one program running on it. Okay, when you write a program and upload it to your Arduino, that is the only code running on the Arduino. Okay, there is no underlying operating system or different programs that you can select and run at the same time. Okay, so this has changed as we've gotten more and more kind of smart devices and smart appliances that now have operating systems and connect to Wi-Fi and get updates and stuff. But if you think of kind of a basic appliance like a washing machine, so not a smart washing machine that you control from your phone, but a good old-fashioned washing machine with just buttons on it, right? That washing machine's only job in the world is to be a washing machine. There is a microcontroller in there reading the button presses and then controlling the motors to spin the thing and the valves to let the water in and all that stuff. Okay, so when you think of a microcontroller as opposed to a computer, that's kind of what we're talking about in this class. Okay? The ATmega 328P is the name of the actual microcontroller on the Arduino board. Okay, so Arduino is a brand, it is a company. The larger physical Arduino, which I didn't have a picture of on these slides, right, is really kind of a breakout board for the microcontroller chip. which we will see in a minute. So ATmega 328P refers to the microcontroller chip that's actually on the Arduino board. And most of you took or I guess about half of you took MATLAB, half of you took Python. Arrays in MATLAB start counting the index at 1, and we count left to right, right? In Python, I guess it starts counting at 0. Forget that for now. Registers, we're going to start counting on the right and start counting at 0. Okay, so when we talk about an 8-bit register, bit 0 is there, bit 1 is there, and so on up to bit 7 is here. Each bit can only be either 0 or 1, so it's not like an array in MATLAB or Python where this could be 5 or string or some other variable. Right? Only 0s and 1s. This is called the most significant bit over here on the left, bit 7. That's called the least significant bit over there on the right, bit 0. Okay, so this is the terminology we're going to be using when talking about registers in this class. Don't get them mixed up with arrays in MATLAB. Okay, conceptually, yeah, it's just kind of a thing that's storing a different value in each one of these blocks, but if you count from left to right or start counting at 1, you're just going to get mixed up. Okay, questions on that so far? Okay, this is kind of the setup, and then we're going to get to the Tinkercad stuff, hopefully in like 5 or 10 minutes. All right, so again, this is the actual microcontroller, right? It's just an integrated circuit. It's got a bunch of pins numbered counterclockwise, starting in the top left, right, with that little notch. This is just kind of the convention for how IC pins are numbered. Those pins have different functions. Some are for power, some are for ground. We've seen this before. The remaining ones, the digital pins, are broken into what's called ports. So we see PD, PB, PC. There's 3 ports that are kind of like a bank of pins that are grouped together when we're controlling them. Each port has 8 bits. Each bit port, and I'm going to go through this kind of fast because this is kind of some of the background stuff that you actually don't need to know when ultimately using the Arduino. So for example, PB0 is port B bit 0, and that is on this diagram somewhere right there, right? And it starts to get confusing because port B bit 0 is on pin 14 of the microcontroller, right? So that the physical pin number, port B bit 6 is on pin 9. These pin numbers don't line up with the port bit numbers, okay? And they're kind of out of order, like where the PC 6 is up there for some reason. You don't have to worry about that too much, okay? But the point why we care about those ports and those bits is we can use them to control the pins with registers. So I'm going to skip through this slide actually. This will be when I upload it in Canvas. We're just going to kind of do that live in Tinkercad instead. So for example, and I'm actually going to skip through this part too because we're just going to do it in Tinkercad. But again, you can kind of go back and refer to this on Canvas. All right. So that part that I just showed you, that was kind of just looking at this thing and the pin numbers on it, right? When you look at your physical Arduino, you're looking at the pins over here. This is what I mean by breakout board. This just kind of adds a row of header pins that you can easily put jumper wires in instead of working with this thing directly on a breadboard. Okay, the Arduino also adds a bunch of other stuff, right? It has a USB port, it has a reset button, it has a barrel jack and an onboard voltage regulator, so you can plug between a 7 to 12 volt power supply into this power jack and it will produce a regulated 5 volts for all the logic level stuff on the Arduino. You don't get all of that if you just use this thing on a breadboard. You would have to add all of that stuff separately. So that's kind of what when I say the Arduino board versus the microcontroller itself, that's what we're talking about. Okay, so, and then again, somewhat confusingly, the pin numbers on the physical chip and the port bit numbers don't necessarily line up with the pin numbers on the Arduino. So like where is PB3, which is this one, right? That's the physical pin 17 on the microcontroller. That's not the same as Arduino pin 3, and there is no Arduino pin 17, right? So there's kind of just no relationship between these pin numbers and the pin numbers 0 through 13 here. Again, background information, don't worry about that. One of the documents on Canvas that is going to be your new best friend is this thing. This shows both. It shows all of the labels for the microcontroller itself, but you don't really care about that. What you care about is what you're plugging into the Arduino pins, okay? There is a massive amount of information there. I do not expect you to absorb it yet. We're going to be learning kind of piece by piece throughout the next few weeks where you go look up, okay, I need this functionality, which pin do I use? That is overwhelming and scary. Don't worry about it yet. Hey, we're kind of today going to be zoomed in on this part here. Again, I'm going to skip through this, and we are just going to pull up Tinkercad and kind of do this live. So I'm going to, well, Tinkercad, actually I'm going to give you a brief overview of what we're going to do on Canvas first, or what you're going to need on Canvas. So if you scroll down to course reference materials and tutorials, the stuff under Arduino documentation, this section is now your new best friend on Canvas, okay? There is a C programming reference. So this is not unique to Arduino. This is just for, how do I do a for loop or a if-else statement in C, right? So again, you should have taken another programming class. So like here's a while loop. You should understand those concepts, right? If-else statements and variables. I'm not teaching you that, but I don't expect you to know the syntax yet, like where do the commas and the parentheses go and that sort of stuff. So clearly you can just Google that, but if you kind of want the stuff we're going to need in this class all in one document, that is here. We have the pinout diagram. This is what I just showed you. So this is going to have all these different functionalities we're going to learn about on the different pins. We have the ATmega 328P datasheet, which is a whopping 442 pages long, some nice light reading. This is not something you sit down and read through like a textbook. We are going to go to kind of certain pages in this thing to look up information about certain registers. I have also, both for my sake and yours, pulled some of that out into a more condensed document that is only 3 pages long. That is most of the stuff we're going to need in this class. So while I do want you, and we are going to be looking up in lecture, kind of where do you actually find the information in the data sheet, this is sort of a consolidated reference so you don't get lost in the noise of all the extra stuff that is in the 400-page data sheet. All right. Our goal in Tinkercad today is just to blink an LED. Actually, hopefully, pending time, blink 2 or more LEDs, but we're going to do it with registers. Okay? And I want you to, again, follow along and do this because you're basically doing yourself a favor and getting started on homework 6. And you are then going to have this as reference material when you are building your robot. So we're using LEDs for these circuits because the wiring is simpler than the H-bridge, but the code is the same. Okay, when you want to steer your robot, you are going to be setting digital pins high or low, and that's going to correspond to whether your robot is going forward, backward, turning left, or turning right. Okay, so we are going to do all the code just with LED, and then depending on how far we get today or on Monday, we're going to add buttons. Again, your robot isn't going to have physical push buttons on it, but it's going to have other sensors that it's going to react to, right? So the concept of inputs and outputs is the same. Just using LEDs and buttons kind of keeps the hardware simpler so we can focus on the code for now. Okay? And again, depending on whether you like circuits or code more, this is either going to be more exciting or more boring. I think this is a lot more fun to teach because it's more interactive and I hate just standing here and writing equations down. But if you really hate the coding, sorry. All right, create a new circuit. Add an Arduino and a breadboard. Orientation is up to you. I kind of prefer to put them both in portrait orientation like this by rotating them. Kind of first general step here, connect your power buses. Don't just do this. I can't tell you how many times I taught this class last time and I would walk around and see students just with a bunch of straight green wires crisscrossing everywhere. Okay, so use color coding and make them neat so it is easier to trace and debug them later. So you can do that either when you start adding a wire, you can click to route it, right? And I think I showed this one back when we first used Tinkercad at the beginning of the class. And then you can change the color up here, right? And if you've already added a wire, you can click to move those points or double click to add new ones. Okay, so again, part of this is kind of personal preference and style, but come on, double click, there we go. I strongly recommend not just kind of having crisscrossing green wires everywhere, just like with a physical breadboard. As that gets messy and you add more stuff in the circuit, it's going to get harder to debug. All right. Great. Power and ground from the Arduino, 5 volts and ground connected to power buses on the breadboard. That's kind of your basic starting point. I'm going to add an LED to the breadboard. Okay. Again, personal preference as to where you put it. I'm going to put mine there. Now, I am going to connect mine to Arduino pin 7. I want you to connect it to a different pin. Do not use pin 7. So you can follow the process I am doing when we look at the diagram, but you are not just literally copying what I'm doing on the screen without understanding what's going on. Okay, so I'm going to connect the jumper wire from pin 7 to the positive side of my LED. And then remember, we need a current limiting resistor. 220 ohms is a good value. Okay, I'm going to add a current limiting resistor from the other side of my LED to ground. Okay, I have my LED wired, but it's not going to do anything about hit start simulation because I haven't written any code to turn the LED on. Okay, I will pause for a second to make sure everybody is kind of caught up there with having your circuit wired and keeping things neat. Actually, while we're doing that, we're going to switch to pull everywhere real quick. So I'm just going to pull this up in another tab as you're working. This is just kind of for me to get calibrated as to things I need to explain. So this first one is just a poll for do you know how binary numbers work? Okay, because that is something I kind of glossed over all the ones and zeros there. This is something that we don't actually need to understand today, but going forward, like if I ask you to convert the number 12 to binary, or what 1010 is converted to decimal, I don't know if that really is just something people kind of pick up or formally gets taught in a prior class. So for my sake, I want to see what the result of this poll is. I'll leave that open for another 30 seconds. Again, if you're still working in Tinkercad, just switch over and answer the poll real quick. Okay, 10, 5, 4, 3, 2, 1, deactivate. Responses, okay, only 37, okay, it's pretty much a 1/3 split between yes, sort of, and no. So again, we don't actually really need to understand it for today. I will go over that in lecture next week. Another quick one, and I kind of had an informal hand raising for this before, but so I have it in a poll. On a scale of 1 to 5, where 1 is I've literally never used one, and 5 is you consider yourself proficient, how comfortable are you with using an Arduino? Okay, again, I'll give that like 15 seconds, just answer real quick. Don't think about it too hard, whether you're a 3 or 4 or whatever. I'm looking for just a trend here. Okay, 5, 4, 3, 2, 1, deactivates. Okay.
Wait.
Oh, okay.
No.
Activate again. Still active. Yeah, if you're having like severe pull everywhere technical difficulties, then I'm going to hold up too much. So are we good? Okay. 5, 4, 3, 2, 1. Deactivate. Okay, and that one, about half the class said 1, so not at all, and then there's kind of a decreasing thing going forward. So again, kind of what I've expected. Third question. This is another trick question. If you're here, don't answer it.
Oh.
Okay? Retract your answer if you answered it. Don't answer it. Don't do it.
But it's such a fun question.
We can just do, okay. Don't answer the poll everywhere. Raise your hand if you've programmed in C before. Okay, so again, most of the class I think took either the Python or MATLAB course. Okay, we're down to 0, so either word got out that I did this no, 1. There's somebody sitting in their dorm somewhere answering this question. Okay, if you're here, don't answer it. Delete your answer. I'm going to close it in 5 seconds. 5, 4, 3, 2, 1. Okay, again, thank you to those of you who are here. I really don't feel like doing academic integrity hearings. Okay, that's it. Last trick question for today. We're going to switch back to Tinkercad. All right. First, I have to remember what I was doing. Hold on. All right. We have this wired. Click on code. this looks fun, but you're not 12, so we're going to switch to text coding. Right? Drop down, text, continue. Sorry. Okay, I am going to zoom in, hopefully to make this a little more. Can people in the back read that? Okay. All right. This is kind of your standard Arduino code that you will get. When you install the IDE and start a new program, you'll get something like this, okay? It has a setup function, so that is code that only runs once. And then it has a loop function that loops forever. Remember, this is the only program running on this thing, so you never want this program to end because there's nowhere for it to go. There's no underlying operating system or anything. So when you think of a piece of hardware, again, there might be some stuff you only want to do once when it first boots up, when you first power on your washing machine, and then it just kind of needs to respond to button presses and do the same thing forever. And then, again, I talked last time, we have these kind of nice Arduino commands that are kind of human readable. So pin mode is setting whether one of these pins is an input or an output. And digital write is turning the pin on or off. So if you just run this simulation, you can see your external LED is not going to do anything yet, but the little onboard LED there should blink on and off. Okay, and that's what this LED built in here is for. Okay, and this is kind of a good thing to come back to. Again, I posted something on Ed Discussion yesterday that I think a bunch of people have seen already. If you don't think your Arduino is working at all, like there might be something physically wrong with your Arduino or you're having trouble uploading your code, this is your fallback, right? Like this should always work. If there is nothing connected to your Arduino and you just open to go to like File, Examples, Blink in the Arduino IDE on your computer, this should work. Okay, if that doesn't work, then there's something wrong with your USB communication or something wrong with your Arduino board. Okay, so kind of remember that as a fallback, but we're not going to do that because we're not using Arduino functions in this class. We're doing it the hard way. Stop the simulation. It won't let you edit the code of the circuit while the simulation is up. Delete all of that. Okay? We're going to start out with a main function like this. So int space main parentheses void. So the void just means this is a function that's not returning anything. Open curly brackets, close curly brackets. Okay, so this is the main function. This is what happens when the thing first powers on. Okay? Inside the main function, and again, how you choose to indent things is up to you. I think exactly how Tinkercad does it. It looks like it's about 2 spaces. We're going to do a while loop that is just while 1. Okay, so C treats 0 as false and anything other than 0 as true. So I could put while 2 there if I wanted to or something. But this is basically the same functionality as those Arduino setup and loop functions. So right here I have code that only runs once, and then inside the while loop, double backslash is a comment. Inside the while loop, I'm going to have code that loops forever. Okay, so same, for those of you who have seen Arduino before, kind of same idea as the setup and loop functions. Okay, for this first initial example, all we want to do is blink that LED. Okay, so kind of the same thing that example program was doing for the onboard LED, except we want to do it with that external LED. So first, we need to tell the Arduino that we want that pin to be an output. Okay, so we are going to set pin as output using something called the data direction register. So switch over to, hopefully you have all these browser tabs open. Switch over to the Arduino Uno pinout diagram. Zoom in, come on, is it going to let me scroll to the right? Not quite. Zoom in over here and look at this yellow column for the pin you picked. You should see PD or PB something depending on which pin you picked. Okay? So find that. I picked PD7 in this case. Okay? So for me, that's PD7. I am going to set something called the data direction register, which is DDRD for me. If you put it on port B, if it's one of these pins up here, then it's going to be DDRB. Okay? Now, by default, that register is all zeros. All the pins default to inputs. Okay? Now, the way we're going to write out the value for an 8-bit register is 0B as the leading text, so that's telling C that this is binary. And 1, 2, 3, 4, 5, 6, 7, 8. Okay, so by default, I'm just showing you what the default value is there. Okay, by default, all of those are zeros. I am now going to count from the right and set the pin I'm connected to 1 because that tells it it's an output. Okay, 0 in this register means input, 1 means output. So in my case, counting from, let's see, over here, right, I'm at PD7. That is going to be the 7th bit, which is the farthest on the left in the registers. Remember the slide, we start at 0 and we count from right to left. So in my case, to set PD7 as an output, I'm going to change this one to a 1. Okay, now, show of hands, how many of you have learned bit shifting before? Okay, I'm going to show bit shifting. If you like bit shifting better, you're free to use that. So this is kind of either a love it or hate it thing, depending on what you learned first. For me, I like being able to look at those 8 ones and zeros and think, okay, those correspond to these 8 physical pins. I know which one is high or low. Some people look at that and think, I hate counting the zeros because it's too easy to mess up. Like if I had picked one in the middle somewhere, if I was on Arduino pin 5, then I would have to go, okay, this is pin 7 there, or bit 7, bit 6, bit 5, I would have to change that one to a 1, right? And then that's just difficult to look at. So another way to write the same thing is to do this. You can do DDRD equals 1, left shift, so double left caret thingy, whatever that character is called, 7. And that is going to move a 1 over 7 spaces to that bit. So those 2 lines of code do the same thing. You can use whichever one you prefer. Yes?
Sorry, so if you chose one of the ones that is one of the B ones, like for example 8 through 13.
Can you talk slightly louder?
Yeah, sorry. If you chose one of the ones that's a B pin, so 8 through 13.
Yes.
How would that change the 0B? Or then would your numbers, would you only have the amount of like zeros that corresponds to the range of 8 through 13?
No, so sorry, that's confusing. Right, so even though there's only 1, 2, 3, 4, 5, 6, there's only 6 pins labeled here, it's still an 8-bit register. So you would still do, well, this gets more complicated into how the binary numbers work. Technically, I don't think the leading 2 zeros matter. So like, let's say that, for example, I picked pin 13, PB5. Okay, so if I did pin 13, PB5, I can write DDRB, so capital B is what's referring to the register, the lowercase 0B is for binary, that has nothing to do with the port. That would be 7, 6, 5, 4, 3, 2, 1, 0, okay. I could write that. I would have to run it to be sure, but I think that is equivalent to writing that because the leading 2 zeros don't matter.
Okay.
So again, this is getting into, we haven't really talked about how binary numbers work. I could convert this to decimal. I said like 127 or whatever that is, and write DDRD equals 127 if I wanted to. I might have that wrong, but you could write the decimal equivalent and the code would still work. So in this case where you could drop the leading zeros and it's still the same binary number, then that would still work. But again, for me it helps to write out all 8 because it just helps to think of each, it's an 8-bit register no matter what. Even if this part of the Arduino, again, it's kind of weird how the Arduino is laid out. On kind of the text just printed on the Arduino board, these 5 over here are labeled as analog inputs. So you don't typically use them as, you can still use them as digital pins. So they're part of port C here. And I forget, okay, and then there's this weird, like, there's this header thing down here that has male jumper pins on it, and that actually has additional port B pins. on it. So there are other pins distributed around the board that aren't necessarily right here. I mean, I think that might still only get you up to 7 port B pins. I forget if there's another one hiding somewhere. Does that make sense? Okay. Okay. I am going to delete that extra stuff there and comment this out. Okay. And again, that is the same. Both of those are the same in my case as doing pin mode 7 output. Okay. That's what this Arduino language command is actually doing behind the scenes, right? It is just, all it's doing is setting the corresponding bit in this data direction register high. Okay, it's just doing it in a much more user-friendly format and hiding what it's doing kind of in the background. Okay? So everybody have your pin set as an output. Okay, yes?
Sorry, could you clarify how to define like which group the pin is in, like the DDR or something, and how
So,
is
look at pull up this diagram and look at the yellow column here, the PD6, PD, which pin did you pick?
13.
Okay, so 13 is PB5, that's port B bit 5.
Okay.
So you would do DDR-B instead of DDR-D.
Gotcha.
Okay?
And the position of the 1 would be from like counting the number of digits from right to left and to the 5th position.
Yeah, so this is, PB0 is there, just remember to start counting at 0, right? PB1 is there, PB2 is there, PB3, PB4, PB5.
And the 0B for the front is just like a standard.
Yeah, that's just standard to indicate that this is binary as opposed to a decimal number. Again, I could write, I don't think I'm doing this conversion in my head right, but I could write like that, or whatever 2 to the 7th is, right? So I guess 128, right? I could write that without deleting 0B, and these two would also be equivalent, okay? Okay. Yes?
So if for example, I chose pin 8, which is in the D region, so would my equivalent in pin mode be 8 output or 0 output since it's PB?
So if you chose pin 8 here,
Yes.
right, that is PB0. So it is bit 0 of port of DDR-B. So that would be this one all the way over here.
That makes sense, but then if I was to write the corresponding pin mode command, like you did set.
Oh, so the Arduino language pin mode uses the pin numbers printed on the Arduino.
So that would just be 8.
Yeah, so those go up to 13. Then they don't stop at bit 7.
Got it.
Okay. But remember, you're not allowed to use this one in this class, so don't worry about that too much. Okay. Okay. Everybody think you have your DDR register right? All right. Next, we want to just turn the LED on, okay? We are going to do that with something called the port register. Again, it's going to be either port D or port B, depending on where you put your LED. And that is going to be the equivalent of the Arduino digital write command. So if I want to turn that, I've already set it as an output. If I want to turn it on using the Arduino language, I would do digital write 7 high. And I forgot to mention this, you have to end the statements in a semicolon and see. So if you run it and get some sort of compile error, it might, like, oh, you're missing a closed brackets or closed parentheses or something. It's probably because it didn't know the line ended and it was expecting to end in a semicolon. Okay? This is going to be pretty much the same functionality as the DDR register, where once I have set a pin as an output, then a 1 in the corresponding bit here turns that pin on or high or 5 volts, whatever you want to call it. A low turns it off. Okay, so for me, it's going to be 0B, and then if you don't, again, depending on whether you use bit shifting or writing the register out, you could just copy that to spare yourself from counting the zeros again. Right, so I've set that pin as an output, and now I'm turning that pin on. Okay, so now, if I run my simulation, it just turns on. Right? It's not blinking. Didn't add any more stuff yet. Okay, so this is like the hello world equivalent. I see this. That looks bad. No? Good.
Not that you can use it on.
Okay.
That's kind of your
That is actually going to bring us to a good point about debugging. Okay, so someone's LED is not on. Not to pick on you, but you volunteered that. So your LED is on. That could be because your code is wrong. It could be because you wired your LED wrong, right? And if all you do is hit start simulation and it doesn't turn on, you don't know what. So I'm glad it looks like you have people looking over your shoulder already. So this is kind of like lab 2, but now we also have code, right? You just hit run and it doesn't work. Okay, you power on your robot and your robot doesn't move. You don't know if that's a code problem or a hardware problem or some combination thereof. Something that is going to be extremely useful for debugging code is, good, okay, what was the problem?
My resistor was going to power to the volts, and also I was in pin 4.
Okay, 2 problems. All right, so one way to help debug your code is there's this little thing called the serial monitor at the bottom. In Tinkercad, it's down here. In the Arduino IDE, you go up to the, I think, Tools menu and open Serial Monitor. It lets you print out messages, okay? So to use serial printing, you have to do a line that says serial.begin, parentheses 9600. That is initializing the serial connection via USB with your computer. 9600 is something called the baud rate. So that's initialize serial. So that's the data rate at which it's communicating with the computer. And then if you ever want to print something, you do serial.print ln. That ln makes it print to a new line, so it'll keep printing vertically instead of just scrolling horizontally forever. And then whatever message you want to print, I see your, let me finish this and I got your question. Whatever you want to put in quotes here, so like LED on. Yes, sorry.
What was the 9,600?
It's called the, so the question was what is the 9,600? That is called the baud rate. It is the frequency at which the Arduino and the computer are sending bits to each other. So kind of for the, in the Arduino IDE, it doesn't exist in Tinkercad. In the Arduino IDE, there's a little drop-down menu to select the baud rate. So you have to make sure that what you set in the code matches what's selected in the IDE, or else the data will be all garbled and like printed with wrong characters. Don't worry about it too much, just type the 9600. Okay. And think about it like, if well, this is an interesting aside. Say that I was going to communicate to you by like writing a letter on a piece of paper and holding it up, right? And I said, open your eyes once every second, right? So you open your eyes once a second and you see the letter I'm holding. But if I start holding the paper up once every 1.5 seconds, right, then you're going to miss some of them. So it's like that kind of when the computer is listening, like they're synchronizing the rate at which they're sending information. Okay. Okay. So now, if I run this and open the serial monitor, okay, so I put that print inside my loop, so now it's repeatedly printing LED on, right? But that at least starts to help you differentiate, okay, so say my LED wasn't lighting up, I can look at this and go, okay, I at least know my code is getting there, right? So maybe I have the wrong register, maybe I have my LED wired wrong, but it's not, this gets more important when we get to if statements, right? You have an if-else statement with 2 different conditions and it's not clear if the conditions are being triggered. And we'll see this, I don't think we'll get there today, but when we get to buttons next week, for example, you could do print button pushed, button not pushed. And then you can say, okay, at least my code is detecting the button press even if my LED is not working. This is gonna be really important as you get towards kind of more complicated stuff and building the robot with multiple sensors and outputs. But the caveat there is that serial print commands are really slow. It takes an amount of time for the Arduino to kind of send that string of characters to the computer. So they are useful for debugging, but you should kind of comment them out when you're done. Don't just leave a ton of serial print commands in your code, or it can kind of actually slow down the execution of what your robot's doing. So good habit to get in. This is something I'm going to harp on the TAs about. You know, when you call them over and say it's not working, I want them to ask, well, have you used serial print commands to kind of print out and figure out what your code's doing? We haven't done variables yet here, but variables are another good example. Just like in MATLAB or Python, you might print X or print the value of some variable to see if it is what you think it should be. Okay, you can use it to print out variables. So we'll get to that more as we progress here. But For now, we just want to make this thing blink, right? So we're going to do underscore delay underscore ms parentheses 1000. So that command just causes a delay in milliseconds. Okay? Then we want to turn the LED off. So I'm going to copy that line, put it here. I'm going to change my 1 to a 0. Okay, that's it. It's already set as an output. I only need to do that once at the beginning of the program. Right, but now I want to turn it on and off using port. Then I want to wait for another second. Delay again. Okay, so on for a second, off for a second, and then I'm just going to close my serial monitor, just in an infinite loop that's going to do that forever. Okay, so if I start this, yay, blinking LED. Yes?
Or do you need an underscore before the delay?
Yes, this is a, so there is, the question was, do you need an underscore before the delay? This command is specific to C. There is a different, but nearly identical Arduino command, just called delay, without the underscores and without the ms, that also just does a delay in milliseconds, so I could do delay 1000. That command depends on the Arduino setup function to work. There's a footnote about this at the very end of the homework I just posted. So if we copied and pasted, if we just replaced this underscore delay thing with that one, this code wouldn't work, because that delay command is an Arduino function that isn't properly initialized because we didn't call the Arduino setup function. So if you've used Arduino before and you're used to seeing that one, use this for now. Okay. Yes?
I just have a quick question of like, I know we have like initialized port 7, but say we had like 2 different outputs, wouldn't that second line turn off all of them? Or is port D specifically?
Excellent question, but give me until like Monday or Wednesday to explain that next week. So the answer to your question is yes. We are kind of easing into getting our feet wet here. There is a way to individually control the bits without changing the other ones. So for those of you who couldn't hear, the question was, oh wait, what if you had 2 outputs? Wouldn't this line turn all of them off? Yes, it would, and there is something called masking that will allow us to individually change just one of these bits without changing the other 7. That gets a little more into the binary and Boolean logic stuff, so we need like a little more lecture primer for that. I don't want you to worry about that for today. What I want you to do with the remaining time is add a second LED and blink it out of sync with this one. Okay, so it should be like a railroad crossing flasher, kind of where one LED is on and the other one is off, and then they alternate. Okay, so pick another pin, add a second LED, and make it flash out of sync with that one. Okay, and I'm not going to give that away, at least not for the next 5 minutes. Maybe I'll do it in the last minute or so. Okay, pick another pin. You get to decide whether it is on the same port or a different port. Right, so if you already used port D, you could do port B, or you could keep them both on the same port. Figure out what you need to do with the data direction register, and figure out what you need to do with the port register or registers. Again, motivation here being ultimately you're going to need at least 4 of these for your robot, right? You have 2 motors, an H-bridge for each. Each H-bridge has 2 inputs. That means you're going to need to control 4 outputs for full directional steering of your robot. Oh, and another note here, Tinkercad just makes up these weird random names. What I would recommend doing is give that a name that makes sense to you so you can look it up later, right? So blink with registers or something. And then as we go forward on Monday, so on Monday we're going to add a button, right? So rather than hard coding behavior, how do we react to an input? If you go back to your main account page, you can hit the little gear icon, select duplicate, right? So then you can make a new one and say, LED control with button or whatever, rather than continuing to overwrite the same circuit. So then you kind of build up a library of things you can refer back to. And much of what we're doing in lecture is very similar, if not identical, to the homework, so it kind of also will save you that effort there. The homework is going to ask you to do this with your physical Arduino though, right? So you will need to, you cannot program your physical Arduino directly from Tinkercad, but you can, I believe, either download this code or copy and paste it into what's called the Arduino Integrated Development Environment, or IDE, which is the software that actually uploads to your Arduino. You also need to watch out, because you can make wiring mistakes in Tinkercad, right? Like you can put your wires in the wrong place, but Tinkercad doesn't have, either it works or it doesn't. There's no loose wires or burned out LEDs or kind of faulty connections. So just like in Lab 2, when you get to working with your physical Arduino, there are kind of more physical things that can go wrong. But Tinkercad is still a very good kind of prototyping or first pass environment. Okay, I am gonna at least start adding an LED. Put one on there, and I'm just gonna be lazy and go to pin 6. Anyone have it working yet? Okay. Okay, so I'll kind of start. We got like 2 or 3 minutes left. So I added another LED to pin 6. I can double check over here. So that's port D, bit 6. If I look at my registers here, okay, I already have bit 7 high. I also want to set bit 6 as an output now. Okay, and then here, so I'm basically just only editing one thing here. So the first line there, I just want the red LED on and the green LED off. And then the second one, I now want the red LED off and the green LED on. So I'm going to change that to a 1, right? And now, if I run that, it just alternates them. Okay, so putting them on the same port there made that a little less work, because I didn't really need to add lines of code. It was just changing some 1s and 0s in my existing registers. I could put one on port B too, right? But then I would need to add the DDR-B register and the port B register to control it separately. Okay, so maybe just for the sake of showing that, if I wanted to add a third one, say up here, to pin 8, which remember is port B, bit 0. I don't know, I'll make that one blue. Okay, let me change the color there. I don't know why it won't let me change the color of that one. Oh well. There we go. No, that disappeared. Oh well. So I could add the DDR-B register. That is bit 0 now. So I've set that as an output, and then down here, let's say I want that one on at the same time as the red one. I could add port B, change that to 0, or change that to a 1, and then add another port B, and turn that off there. Okay, and now again, I wanted to make that LED blue, but it's matte for some reason. So now these two will be on at the same time, and that one will, these two will be on at the same time, and then this one will blink out of sync. Something I kind of started off doing well here and then got lazy about, comment this so it makes sense when you come back to it later. Okay, again, different comment styles or ways of explaining these things may make sense to different people. So for your own sake and for the homework, okay, if you submit code with 0 comments, you're going to lose points on the homework. But this needs to make sense to you a week from now, or a month from now when you're building the robot. Okay, so whatever makes sense to you, Make sure you comment it. All right, we are good at 12:05. As usual, I will be here for questions. Thank you and have a good weekend.